Alright, hey guys, this is April 2nd, Thursday. This will be the fourth lesson. Basically what we're going to do for this is starting on page 408. And so what we're going to do is we're going to split this lesson similar to how we did the last one. So we're only going to do about half of it today and then we'll finish it up tomorrow. And so to start with, this is scientific notation. And so the scientific notation is good because if you had a really large number and we wanted to look at that and write it, then we need a different way than writing it like 20 different numbers on the board. And so, or if you had a really small number, it works the same way. So today we're dealing with really large numbers. And so scientific notation is basically always going to have a whole number with a decimal times 10 to some power. So it's always a whole number, some number 1 through 9 here, with a decimal point, then another number, times 10 to some power. And so that is scientific notation, so you just have to be able to identify the form of scientific notation. And so again, it's some number with a decimal, then another number, times 10 to some power. And so that is the form. Now, what this is going to do, what we're going to do today, is basically either move it from scientific notation to the regular number, or we're going to move it from the regular number to scientific notation. And so those are the two type of problems we're going to do today. So if you look on your book in page 410, they give us number 1, which is 84, 00. So that would be 84 million. And so what they want to do, they give it to you, equals 8.4 times 10 to the n. So they just put times 10 to the n. And so the idea is that this number here, 84 million, and then this number written like this, 8.4 times 10 to the n, are exactly the same thing. And so we just have to figure out what the n is. And so to do this, basically we're just going to move our decimal place. And so notice that if it's 8.4, notice we put the decimal in front of the point, in front of the 4. And so what happens here is the decimal is in front of the 4, so we're going to come over here to our big number and kind of put an imaginary decimal right there in between the 8 and the 4. So I'm going to put an imaginary decimal kind of right here, okay? And then I'm just going to count the places to the end. And so it's going to be 1 place, 2 place, 3, 4, 5, 6, 7. However many decimal places that is what the n is going to be, what that exponent over the 10 is going to be. And so that is 7 decimal places, and so that means my n here, n will equal 7. And so this right here would be a 7 would go into that place there. And so that's all we're going to do is move the decimal place here on for these problems. So you have to identify where the decimal would be. So they gave it to you here, so it's 8.4. And so the decimal is in between the 8 and the 4. So that's where it comes here. And basically the way this works, the decimal will always be, because of how form works, the decimal will always be right next to the in between the first and second digit. And so here's the first and second digit, and so that's where the decimal is always going to slot in for these, for the large number of problems that we're doing today. And so then you just count. And so if you look at number 3, so look at 3, we'll go through it. So 3 says 7, 0, 0, 0. Equals 7 times 10 to the n. We want to know what n equals. So again, you have to figure out where the decimal goes at. And so notice here the decimal is just after the 7. The reason they didn't write another number, like it wasn't like 7.2 or 7 point something, is because notice the number that comes to the right of the 7 this time is a 0. And so we don't even have to write it, you just have to put the 7 point and then carry it through. And so our imaginary decimal is going to be right here. So then we're just going to count how many over to the end we have. And so if we count it, you have 7 We can count 1, 2, 3, 4, 5, 6. And so you're counted over 6 times, and so that means our n would equal 6. Since we counted over from our imaginary decimal to the n would be 6. And so this n right here, you would plug a 6 into that. And so 7 times 10 to the 6th is the same thing as 7 million. And so that's essentially how we're going to carry these through. And so I'll try one more with you. Look at number 5. So number 5 says 87 million. Just that. So again, they give it to us 8.79 because again, the decimal is always going to go in between your first and second digit. And then you just keep writing the numbers you see until you get to a 0, and then we don't have to write the 0. And so the imaginary number, the imaginary digit, not digit, decimal, would be right there between the first and second digit. And so then you're just going to count how many times we move the decimal over until we get to the end there. And so you're going to count over 1, 2, 3, 4. And so our n would be 4 for this problem. So n would equal 4. So this, all that is saying is that the exponent there would be a 4. So just take this number and put it over here and then count your decimal over. So y'all can try, y'all need to do 2 through 6 there, and then we're going to move on to the next section. So it's 2 through 6, 2 through 6, we're going to work 2, 4, and 6, we're going to work exactly how I did it on the board. Okay, if you look at the next set of problems, like number 7, 5, 8. So they give us 5,800,000, and so for number 7, they want this written in scientific notation. So what we're going to do is we're going to take this large number that they give us, and we want it written in scientific notation. So it's kind of doing what we just did, but actually going completely through it instead of them giving us part of it. And so we want it written something like this, where we have a number, a decimal number, times 10 to some power. So that's how we want it written. And so remember, the first thing to do is it's always this part, so we have to do the, basically we're trying to get the 9 decimal number just with this problem. And so we're going to do 5.8 because, remember, the decimal always goes in between the first and second digit. So first and second digit, then we go and put the decimal here, and then we're just going to keep writing down what we see until we get to a 0. And so I saw the 5, decimal comes in between, then I saw the 8, and so the 8, and then I saw the 0, so I'm not going to write that because once you get to 0, you stop. And so it's 5.8 times 10 to some power, so I have to figure out what that power would be, which is what we just did a minute ago. And so if I put the imaginary decimal right here, then I'm going to count over until I get to the end, and then that will give me the end. So if I count over, it'll be 1, 2, 3, 4, 5, 6. So I counted over 6 times, so that means my n would be 6. So my final answer would be 5.8 times 10 to the 6th. So 5.8 times 10 to the 6th. Remember, decimal always goes between the first and second digit, and then you're just going to count over to see how many times you get to get this part over here. So, and you always, right here, you always will put just what you see until you get to a 0, and then you stop. So the next problem would be number 9. So they give us 7,300. They want this written in scientific notation. And so the first thing is to identify how we write it right here with the decimal. And so always the decimal goes between the first and second digit. And so the 7 and the 3, that's where I'm going to put the decimal in between. So So I have 7.3, and then I'm just going to keep writing down numbers until I get to a 0. Well, in this case, the 0 comes after the 3, and so it's just 7.3. And then I'm going to do the times 10. Then I just have to figure out what power goes there. So if my imaginary decimal's in here, in between the 7 and the 3, then I'm just going to count over until I get to the very end. And so that would be 1, 2, 3, and so it would be 7.3 times 10 to the third. And so that would be my answer. So, decimal goes in between the first and second digit. Keep writing down the numbers you see until you get to a 0, so it was just a 3 in this case. And then times 10, I moved over 3 times, and so it would be times 10 to the third. And that is writing it in scientific notation. I'll try, let's see, what's a good one to do? All right, look at 11. So 11 is 387.65. Again, all this written in scientific notation. And so they gave it to me with a decimal, that's fine. Remember, for scientific notation, all I want to do is move that decimal in between the first and second digit. And so instead of having a decimal there, I want it written in between the first and second digit. So I want it written in between the 3 and the 8. And so I'm going to move it there. So that would be 3.8. And then I'm going to keep writing down the numbers I see until I get to a 0. And so I have put 3.8. I see a 7, so I'm going to write it. I see a 6, so I'm going to write it. I see a 5, so I'm going to write it. And then I get to the end, and there's no other number, and so that's where you would stop, because that would be basically your 0. And so I would put times 10 to what power? So then I just have to figure out the power part. Okay? So if I move my decimal in between the 3 and the 8, so I have my imaginary decimal in here between the 3 and the 8, so then I'm just going to move the decimal over to the very end and see how many times I've counted over. So it's going to be 1, 2, 3, 4 times. I moved it 4 times, and so it'd be 3.8765 times 10 to the fourth. So, no matter how they give it to you, you can still work it through. Or actually, it'd be 2, not 4. Because we would stop at the decimal place. You just go to the decimal in the answer. So since the decimal here was there, you would just stop there. So you just go to where the decimal place is. In this case, it was only 2, so it'd be only times 10 to the square 2. So I only have to move it twice to get back to the original. So instead of 4, it'll only be a 2. So that's essentially all you have to do on those. Is just you move to where your decimal is. If the decimal's on the end, then you move the end. If the decimal's right here in the middle, then you move to that point. And so it would just be 3.8765 times 10 to the 2. So another one like that, just so we're clear with it, if you had, say, just making one up, wanted to write that in terms of scientific notation, then I would write, move the decimal in between the first 2 digits. So it'd be 8.2 is what I would write. Then I see a 5, so I write the 5. Then I see a 6, so then I'm done. So then it's times 10 to what power? So I'm going to move the decimal over until I get to the actual decimal place in the answer. So it'd be 1, 2 times. And so my answer would be that. And so just put it in there and then move it to where the actual decimal is. So that's going from the bigger number to scientific notation. The last little bit of the lesson goes from the scientific notation back to the larger number. So if you look at 25, this is on page 411, so 25, they give you 5.5 times 10 to the fourth. So that's in scientific notation. So to get it back to the just regular big number form, standard form, you're going to move the decimal that many n number of times. So the decimal's here, and so we're just going to move the decimal 4 times to the right since it's positive. And so we're just going to take that 0.5, 5.5, and I'm going to move the decimal 4 times to the right, and that's my n. And so it's here, so that's 1, 2, 3, 4. Whatever you fill in that doesn't have a number there, that's just a 0. And so it'd be fill in zeros there. And so my final answer would be 5, 5, 0, 0, 0. And then comma over the third number. And so the n tells you how many times to move the decimal, and that's all you're really going to do. And if there's no number there when you move it, you fill it in with a 0. So a couple more of those, and that'll pretty much finish us out. So if you look at 27, it was 1.05 times 10 to the 7th. And so again, this exponent above the 10 just tells us how many times to move the decimal. And so it's 1.05 times 10 to the 7th. So if the decimal's here, I'm going to move it 7 times to the right, and then just fill in whatever's missing with a 0, and that's going to be my answer. So I'm going to just move it 7 times. That's 1, 2, 3, 4, 5, 6, 7. And then I would fill in these with zeros since there wasn't a number there. And so your final answer then would just be 105. Then I filled in zeros. 3 of them, 4 of them, 5 of them. And so your third one would be a comma. And so there would be your answer. So just move the decimal however many times I give it to you. That was 7, so I moved it 7 times. We'll try look at 35. Should be the last one. So 35 says 7.0061 times 10 to the first. And so all this is going to tell me to do is whatever this number is above the 10, that's how many times we move the decimal. And so since the decimal is here, we're just going to move it 1 time this time. And so here it is. I move it 1 time. And so it is 7, 0, and then there's my new decimal, and then it's 0, 6, 1. And so notice I just moved it 1 time now, and so that would be my final answer. So 70.061. So it just tells me to move it 1 time because that number over the 10 is a 1. That number 10 over the 10 was a 5, we would move it 5 times. Just whatever that number is, that's how many times we move the decimal. So that should be good for y'all on this. Again, if you have any questions with it, make sure you get up with me. So your homework would be 2 through 2 through 38. So again, 2 through 6, and then that next section was 8 through 24, and then 26 through 38. And so basically you're going back and forth. You're taking this and writing it like that, and then you're taking this and writing it like that. So you're just going back and forth with it. And so just work on those. We'll do the rest of it tomorrow. So thank y'all. Have a good day.